Hi dear students, please welcome to my lecture. Today we are going to discuss about phases of moon. The outline of my today's lecture is Introduction, Phases of Moon. The main learning objectives of this session are students will be able to understand the phases of moon and relate with day-to-day visibility of moon. In the last lecture we have discussed that moon is a natural satellite of the earth. It is a non-luminous body. It does not have its own light. Moon is visible to us because of the reflection of light coming from the sun. Moon revolves around Earth. Moon, with its gravity, has capacity to attract the water from the oceans and cause tides on the Earth. Now, it is very interesting to know that half of the moon surface is always illuminated by the sunlight. Hence, the visibility of moon varies from place to place every day, and this is what we refer to as moon phases or phases of the moon. Let's look at this particular picture. In fact, it is made up of many pictures. Now, in this picture, we will find the moon's visibility is increasing day by day. Now, here moon is completely dark. A part of the moon is visible here. Little larger part of the moon is visible here. Still larger, and the entire moon is visible to us. So this is how moon appears to us on day-to-day basis. Now what is interesting here is that the visibility is increasing on day-to-day basis. Now we will move on to the next slide, and there we will observe exactly opposite of this particular happening. So now what's happening here is the moon's visibility is decreasing day by day. So first is the entire moon. Part of the moon is not visible. Still little larger part is not visible. About 50% of the moon is not visible. Then little more, and like that you have a day on which entire moon is not visible. So these are called the phases of the moon. Let's understand why moon is visible from totality to nil or from nil to totality. So if you see this particular situation, this is the earth, this is the sun. The light of the sun is falling onto the earth, and here is the moon. Now in this particular case, the light of the sun, which is falling on the moon, has blocked the light onto the earth. Now this situation results into new moon day. Now in this case, the angle of the moon has changed. So if you are here, a small part of the visible moon will be seen. So this is how in this particular angle we will be able to see this much portion of the moon. Now in the third diagram, the position of the moon has shifted to this angle. Now from this angle we are able to see this much of the moon, meaning almost 50% of the moon is visible to us. Now the position of the moon has further changed. We are able to see still larger amount of moon surface, and when the moon has shifted completely from here to here, now we are able to see the entire moon. So this situation is called the first quarter, and this is called as the full moon. So on full moon day, entire moon is available. We are able to see on a full moon day, whereas on a new moon day, moon is not visible to us because the light is completely blocked. Now, the moon, which has come into this particular angle, will start revolving further and move in this particular position. So when it moves in this particular position, which is similar to this particular position, we are able to see this moon, which is called as the last quarter. And similarly, the position of the moon changes further, further, and further. So when it reaches here to its original position, we are back to new moon. Now let's understand. From this full moon towards left and towards right. Towards right, it is called waning moon, and towards left, it is called as waxing moon. So this is a full moon. This is called waning gibbous. This is the last quarter, and this is waning crescent, which later results into new moon. Similarly, when we move towards left, this is waxing gibbous moon. This is the first quarter. This is waxing crescent, and this is new moon. So from here, it takes to reach to this about 14 days, and from here to reach this particular position, it takes about 14 days. In the sense, a month of moon is equal to about 29 to 30 days. To understand more about the other technicalities of phases of moon, let us have a look at this particular video.
Hello. I want to talk to you about the phases of the moon. The concept of the phases of the moon is sometimes difficult for students, and I want to show you a demonstration to try to explain the phases of the moon. In this demonstration, the sun will be represented by a light bulb, and the moon will be represented by this styrofoam ball. Earth itself will be the camera, and you'll see the moon going around Earth, that is, going around the camera later on. The moon is going to be supported at the end of this rod, like so. And so let's turn on the sun. I think you can see that regardless of whether the moon is on one side of the sun or on the other side of the sun, that it's the side of the moon that is facing the sun that is illuminated, and the side of the moon that is away from the sun that is in darkness. So, let's take a look at the demonstration. All right, let's get started. Remember, the camera represents you on Earth, looking up at the moon at its highest point in the sky when it's directly overhead. In this configuration, we're also looking toward the sun, so it's in the middle of the day, and this is the new moon phase, because the moon is directly between the sun and Earth. This means that the side of the moon that is away from Earth is being illuminated by the sun. But the side of the moon facing Earth is in shadow. And that means that the new moon is very difficult to see in the brightness of the daytime sky. Now, let's let the moon orbit Earth. Here we go. And now we see a crescent of brightness coming in on the right side of the moon. That crescent is growing larger. And this is the waxing crescent phase of the moon. Finally, we've gone a quarter of the way around the moon's orbit about the Earth. And so this is the first quarter phase of the moon. As you can see, the right-hand side of the moon, which is facing the sun, is lit and the left-hand side of the moon, away from the sun, is in darkness. So this is the first quarter phase. We'll continue letting the moon orbit Earth. Now more than half of the moon is lit up, and that lit part is growing larger. This is the waxing gibbous phase. And it continues until we've gone halfway around halfway around the moon's orbit around Earth. And we come to here, the full moon phase. In the full moon phase, the Earth is directly between the moon and the sun. And so the side of the moon facing Earth is totally illuminated by the sun's light. And we have a full moon, which is overhead at midnight. Let's continue with the moon's orbit around Earth. Now we see some darkness creeping in. On the right-hand side, the lighted part of the moon is growing smaller. This is the waning gibbous phase. And it continues until we've gone about 3/4 of the way around the moon's orbit about the Earth. And so this is the third quarter moon. Finally, we can continue on. As we continue on, you can see that now the moon appears more and more as a crescent. That crescent moon is becoming smaller. And so this is the waning crescent phase. And we arrive back at the new moon phase. Let's go around once more. And I'll try to move this smoothly and just describe the phases of the moon as you see them. So right now we're starting at the new moon phase. This is around noon on Earth. You see a growing crescent for the waxing crescent phase. First quarter moon. Waxing gibbous phase. Full moon. Waning gibbous. Third quarter moon. Waning crescent. And back to the new moon. Let's try looking at the times when the moon is directly overhead in the sky. We're starting out in the new moon phase, and that means that because the sun is also directly overhead, this must be noontime. Now, as the moon goes around Earth, let's go around to the first quarter phase. There we go. The first quarter phase. We're heading toward midnight. The full moon is overhead at midnight. So we've gone halfway from noon to midnight, and so this must be 6 p.m. So the first quarter moon is overhead around 6 p.m. Let's keep going toward the full moon. There we go. There's the full moon. The full moon is in the middle of the night. We're in the middle of the nighttime sky here. We're halfway around from noon. This is midnight. The full moon is overhead at midnight. Let's continue on. Going around another quarter of the moon's orbit, heading for the third quarter moon. There's the third quarter moon. So we've gone halfway from midnight back to noon, and that must be 6 a.m. So the third quarter moon is overhead around 6 a.m. Let's continue going around. And we're back at the new moon, which is directly overhead at noon. You may have noticed something. Here, the moon appears above the sun. And this actually happens in the sky. The moon is usually found either above the sun or below the sun. This is because the moon's orbit around the Earth is tilted by about 5 degrees relative to the Earth's orbit around the sun. And this means that the moon is usually seen either slightly above or slightly below the sun. But sometimes the moon lies directly between the sun and Earth. Let me show you what that looks like. In that case, we have a solar eclipse because Earth is in the moon's shadow. Notice that a solar eclipse can only occur at the new moon phase. Now, let's take a look at what happens when the Earth lies between the sun and the moon. Here's what happens if the Earth lies between the sun and the moon. In this case, the Earth's shadow falls on the moon, and a lunar eclipse occurs. Notice that this can only occur when the moon is in its full moon phase. So I'm going to turn the moon in its orbit, and you can watch it move out of the shadow. And here we are, back near the full moon phase.